Tides are periodic changes in the height of the ocean surface at a particular place. The picture on the right shows the difference in the ocean surface height during low tide and high tide. Tides are the longest of all waves, and its wavelength equals 1/2 of Earth's circumference. Tides are caused by a combination of the gravitational forces of the moon and the sun. So they're considered forced waves because they're never free of the forces that causes them, which is the gravitational forces of the moon and the sun. There are several reasons to which why it is important to study the tides. Understanding the tidal range of a particular estuaries can be relevant for coastal navigation. For example, these four industrial cranes, valued at approximately $1.25 million each, arrived in San Francisco Bay from Shanghai, China. They had to be transported beneath the Oakland Bridge to reach their final destination, the Port of Oakland. The tidal range of San Francisco Bay when these cranes were transported was 4.1 feet, and the bridge had a motion of approximately 6 inches. With light chop on the bay and winds blowing at around 10 miles per hour, there was very little room for error. Only with detailed knowledge of the tidal cycle and a skillful pilot, the cranes cleared the bottom of the bridge by about 6 feet. Remember, tides can move up and down by about 10 meters throughout the day. Knowing the tides can be relevant for beach safety, surfing, and efficient fishing, since fish may concentrate during the ebb flow of tidal currents. Learning how to read a tide calendar, such as this one, before heading out to the shore is useful and can keep you safe. Coastal zone engineering must also consider the tides, specifically the tidal ranges, to build safely on the coastline. If the tides are ignored, destruction and fatalities may occur. This is a photograph that shows a bike path constructed alongside a rocky shore in Rio de Janeiro, Brazil. After the first winter storm combined with a spring tide, surging waves destroyed the bike path, killing about 7 people. And finally, tidal energy can be harvested, providing a source of renewable energy, a much needed resource in current times. Here we see electricity generated at the La Rance tidal power plant in Saint-Malo, France. When water is filling up, water from a falling tide flows out of the estuary, it turns the turbines. Electricity is also generated when the high water from a rising tide enters the estuary and turns the turbine in the other direction. With climate change and sea level rise, understanding what the tides are doing now and in the past can also inform sound coastal policies that addresses climate change. With that in mind, I'm going to give you a brief overview of the two theories that explains the tides. And in the next videos, I will explain each of those theories. So the two theories are, number one, the equilibrium theory proposed by Isaac Newton, where he considers the position and attraction between the Earth, Moon, and Sun as the main factors. But he disregarded ocean depth and the presence of continents. Newton assumed that the Earth is made only of water to explain how the tides work. A few years later, a French scientist, Laplace, developed a dynamic theory of tides, in which he considered ocean depth, the continents, and the Coriolis effect.